Okay, so here's the video solution for the sixth circuit. I see two batteries this time, and they are kind of opposing each other. So let's start with that. These two batteries together, if I put them together, they would make one battery with the positive terminal over here and the negative terminal over here. Because this one's 34 volts in this direction, and this one is 3 volts in this direction, they subtract from each other. There's a 1 positive 34, negative 3. So really we're dealing with a voltage of 31 volts. Okay, so I'm just going to make a note of that. This is 31 volts, the batteries together. Okay, now we're going to analyze the circuit. We have to figure out how much current is coming out of those batteries. That current is going to be equal to the total voltage, which we just figured out is 31 volts divided by the equivalent resistance. So how much resistance is attached to these batteries? We need to figure that out. So the equivalent resistance is going to be equal to, well, let's see what's in series. We've got 10 in series, so I'm going to add 10 plus, and now I see a group of resistors. So 20 to the negative 1, 30 to the negative 1, and we'll raise that to the negative 1. And I see one more, 40. So let's figure out what that is. 10 plus 20 negative 1 plus 30 negative 1. Raise that to the negative 1 power plus 40. All right, we get a total of 62 ohms. So this is 62 ohms are equivalent. That tells me that the current in the battery, the currents coming out of the batteries total, are 31 divided by 62, that's 0.5. So half an amp, or 500 milliamps. We'll just say 0.5 amps. Okay. So what resistors have that current? Anything that's in series with the battery. So I can say I1, so that's the current for through the 10 ohm resistor. That's 0.5 amps. And I can say that I4, that's the current going through the 40 ohm resistor, is also 0.5 amps. The current's going to split between the 20 and the 30 ohm resistors. We'll do that later. But because I know I1 and I4, and I know R1 and R4, I can figure out V1 and V4. So V1 equals I1 R1 0.5 amps times 10 ohms. So the voltage drop V1 is going to be 5 volts. V4, I4 times R4, 0.5 amps times 40 ohms, 20 volts of drop. Overall, there's going to be 31 volts of drop from this point to this point. There's going to be 31 volts of drop, and I've done 25. So I can say 31 volts total of drop minus 25 volts, which is V1 and V4, give me what's left for this parallel branch. Either branch I take, it's going to be a voltage of 31 minus 25, I think is 6 volts. 6 volts. That tells me that V2 equals 6 volts, and it also tells me that V3 equals 6 volts. Okay, the only thing left to do is I2 and I3. So I2, the current going through 2, is going to be that 6 volts of drop on that resistor divided by the 20 ohms of resistance. 6 divided by 20 is 0.3. 0.3 amps. So the 0.5 amps has to split. So we have 0.5 amps here, and it's going to split into 2 pieces. And I know that 0.3 amps is going this way, and the other one, so I3, is equal to 0.2 amps, because I have to make 0.5 amps. When they join up again together, they have to be 0.5 again. The other way I could do that is by doing 6 divided by 30, and 6 divided by 30 is 0.2 amps. That's it for this video solution. Let me know if you have any questions. Hope this was helpful.